All right, so let's jump into number 5. We're gonna use the function to find the values that are asked in the following questions. So we're gonna look at the behavior of the function of the graph and answer the following. So the first one is, where is the derivative of the function undefined? If you remember, there's only two occasions where the derivative is undefined. That will be whenever the we have a corner on the graph, or where the function is has a point that has a tangent line that is vertical, right? So what we can see here is that in any point, as we get over here closer and closer, those points are going to become vertical. So at x equals 1, the graph is turning vertical. So we're going to say at x equals 1, the function is undefined. Now let's find where are the critical values of f. Well, besides, we will have to find both occasions, right? Where the derivative is zero. Sorry, where the derivative is equal to zero, or where the derivative is undefined. So we can see here that there's two occasions where the derivative will be zero. Those are the two cases here. So it'll be at x equals 2 and x equals 0. The other one will be whenever this is undefined, but that number is not part of the domain of the original function. Remember that that's one of the conditions in order to be a critical number, is that you need to be part of the domain. Well, we can see here that the function does not have x equals 1 as part of the domain. The reason why is because it is not defined there. Right, so now we're going to move on to the local min. The local min will happen whenever we have the lower part of the value, right? And this example is this one. We're going to have a local min at x equals 2. At x equals 2. X equals 2, you're going to have a local min. But can we say what is the actual local min? The actual local min, is the value of the function, which is at 2, but the local min is going to be 4, right? It's going to be 4. So you know where it's going to be at 2, but the actual local min is 4. Same argument for local max. The local max is going to happen in the top of the mountain. That happens at x equals 0. But the actual local max is the actual y value. The y value at 0 is 0, right? So for this example. So we found the location, but also we found what is the actual min and max. The next part is to find the global min and where it happens. Well, this would have been a local min, but actually we see that there's even more numbers that are lower than that local min. In fact, we can argue that this actually says that this is going to keep going down lower and lower, lower without a boundary. So there's no such thing as one number that is the lowest of all the values of the function. So what I'm saying here is that there's no local min, global min. There's no global min, and so that means that this does not occur anywhere. Same argument for local global max. We can say that this is a local max, but there's higher values here, right? Any number over here is actually higher than this global local max. So furthermore, this is saying that this is going to keep going higher and higher without any boundary, meaning there's no such thing as one single value that is greater. No single value in the function that is greater than all the values of the function. So this is a perfect example where there's the global max does not exist. So it does not occur anywhere. And so lastly, we're going to find out where is the derivative greater than 0. And that happens whenever the function is increasing, right? We know it's increasing from the negative infinity all the way to here, and increasing from here to here, right? That's where the function is increasing, right? Where the slope is positive. So if we want to translate that into the location of x where that happens, we can say that it's happening from negative infinity all the way to 0, and from 2 all the way to infinity. Right, so in that regions, that's where the function is increasing. So that means where the derivative is positive. So we're going to say it's from negative infinity to 0, union from 2 to infinity. And the other argument would be, well, where is the derivative less than 0? In other words, where is the function decreasing? So we can do the same thing. We're going to say it's decreasing when it's going down, when the function is going down. It's changing by going down. And we can see here that that's going to happen between 0 and 1, and from 1 to 2. So we're going to say from 0 to 1, and from 1 to 2. And there you go. So we found where is the derivative less than 0. Alright, so that was it for this example. I hope you guys found this helpful. Please let me know if you have any questions, and I'll see you guys